Hi, we are looking at Chapter 3, Section 3, Proving Lines Parallel. First thing you want to take notice of, there will be exactly 6 ways to prove that lines are parallel, okay? And in this particular section, we're going to look at 4 of those ways, and then in the next section, we'll see the other 2. Okay, so the first way is converse of the corresponding angles theorem. And so in this situation, all we know for sure is that we have 2 lines being crossed by a transversal. And according to this, if we have a pair of corresponding angles that are congruent, then we're guaranteed that the 2 lines are parallel to each other. And do you recall how to mark lines parallel? That's right. You go ahead and you put 2 arrows on the line. So if we know angle 2 is congruent to angle 6, we'll be guaranteed that line K will be parallel to line L. Now notice, this is just one pair of corresponding angles. Of course, there are 4 different sets. If any of those turn out to be congruent, you're guaranteed your lines are parallel. The second method of proving 2 lines parallel is the converse of the alternate interior angles theorem. And that one says, again, if I have my 2 lines being crossed by a transversal, and I know that my 2 alternate interior angles are congruent to each other, then once again, I'm guaranteed that the lines will turn out to be parallel. There are 2 sets of alternate interior angles. I just highlighted this particular set. If the other one is also congruent, that would be sufficient to prove the lines are parallel. Okay, the third method that's on this first page is the converse of the same side interior angles theorem. Be sure to fix the typo there, same side interior angles. So again, we have our 2 lines being crossed by the transversal. And notice this one says if the 2 angles are supplementary to each other, if I find out that the measure of angle 3 plus the measure of angle 6 equals 180 degrees, then I will also be guaranteed that the 2 lines are parallel to each other. Okay, so again, we have no symbol to mark supplementary, so we're just going to stop with that. Okay, on to page 2. Okay, this is the 4th method to prove lines parallel. Again, this one I'm not that fond of, but it can be used. It's the converse of the alternate exterior angles theorem. And so it says that if you have a pair of alternate exterior angles that are congruent to each other, you can be guaranteed that the 2 lines will end up parallel to each other. Again, there are 2 pairs of alternate exterior, one more time, 2 pairs of alternate exterior angles. I've only highlighted this pair. If the other pair is also found to be congruent, that would be sufficient to prove the lines parallel. Okay, we're moving on to page 3. Okay, on page 3, we find some examples of how we're going to use these theorems to prove our lines are parallel. So, in this first one, it's asking you to find x so that the 2 lines, AB and DC, end up parallel to each other. So again, just to help me out here, I'm going to go ahead and make those 2 lines orange. I'm not going to mark them parallel yet because, again, that's what we're trying to find out. So I look at the angles that have been highlighted and ask myself, well, what kind of angles are those? And if we look carefully, you should be able to see the Z shape happening. And once that Z shape happens, that tells me that these 2 guys are alternate interior angles. So I look back and I say to myself, if alternate interior angles are congruent, then the lines are parallel. So in this case, if 3x plus 20 is equal to x plus 50, then AB, line AB, will end up parallel to line DC. So what value of x makes that true? We go ahead and we do our algebra. And by magic, we find out that x turns out to be 15. Now, as long as x is 15, these two lines are parallel. If x is any other value besides 15, then the two lines will not be parallel, the two angles will not be congruent, and it doesn't work out the same. So again, as long as x is 15, this works. If x is anything else, it does not work. Okay, so in the next example, we're being asked, is line A parallel to line B? So again, I take my highlighter and I just take a look at those two lines, make them orange again. And then I look at this and I say, okay, well, I have this one pair of angles here, and those are same side interior angles. We can see the C that's being formed. Okay, and I could find the value that makes those two supplementary, but that would be forcing A to be parallel to B. So I need to find the value of x that definitely works. Okay, so the x, I am guaranteed that those vertical angles must be congruent. And if that's the case, then I can find an x that would make this pair of vertical angles equal, and it has nothing to do with lines being parallel. So I go ahead and I set 5x, oops, off the page, set 5x minus 20 equal to 3x plus 30. And then I'm going to go ahead and solve for x. Okay. I solve for x and I find out that x has to be 25 for my vertical angles to be congruent. And again, vertical angles must always be congruent. So I take that 25 and I'm going to go ahead and plug it in to the same side interior angles. So when I do that, 2x plus 10 becomes what is that, 60. And when I plug it into 3x plus 30, I get 75 plus 30, which is 105. So are 105 and 60 supplementary to each other? And the answer to that is nope. So they are not supplementary. So A is not parallel to B. And that's the end of that example. Let's move on to the next page. Okay, here we are on page 4 of the Chapter 3, Section 3 handout. And it's a proof, and you'll notice that I've taken the liberty of marking the picture with the given information, and I've also started our proof and written the givens as my step 1. So please stop the video if you need to and do so that you can be caught up with me. Okay, we're back, and I look at this, and anytime you see or you're given that two lines are parallel, please, the next thing that should pop into your head is, aha, think special angles. Okay, that's what you want to think. Because anytime lines are parallel, I have those 4 different sets of special angles that might be helpful to me. I also want to take a look at the fact that I'm trying to prove these two lines parallel to each other. And again, I usually am going to accomplish that by the converses of the theorems about the special angles. So I take a look here, and of course, the thing that jumps out at me first is the fact that I see this zigzag happening, and with the zigzag comes alternate interior angles. So I'm going to go ahead and mark this pair of alternate interior angles congruent, And I'm also going to say it in my proof. Okay, so here's step 2. Angle C congruent to angle 1. You'll also notice I took the liberty of adding the number 1 to the picture just so I don't get caught up in writing all of the angles by their 3-letter names. The numbers can be helpful. And the reason again for that step is if parallel lines are intersected by a transversal, then alternate interior angles are congruent. You could also have said the alternate interior angle theorem. So, with that being said, we are then take a look at our picture and what's marked at this point. And if you tilt your picture, you should be able to see a nice little F happening. Do you see that F happening here? And when we have an F occurring, that's corresponding angles, and if we check it out, those corresponding angles are now congruent. I just have to say it in my proof. So in step 3, I'm going to say that angle A must be congruent to angle 1. And if we look back in our proof, can you see the reason why that would happen? That's right, it's either transitive property or substitution, whichever strikes you. At which point, if angle A is congruent to angle 1, I have enough to finish this proof. So see if you can come up with the reason based upon looking at your picture. Okay, so again, we're done with our proof. Segment DA must be parallel to segment CB, and our reason is converse of corresponding angles theorem. So we are going to stop this video. The remainder of the examples we will work on together in class. Have a great day. Bye.